So welcome back. 95%, that is how much of our universe is currently missing from our textbooks. Now we look at the star, the galaxies and the nebulas, we think that we are seeing the universe. But in reality, we are just looking at the form of a top of a very deep and very mysterious dark ocean. For decades, the greatest mystery in science has been divided into two camps: dark matter and the invisible glue that holds galaxies together, and neutrinos, the ghost particle that stream through our bodies by trillions every single second. Until now, we thought that these two lives in a completely different world. We thought that these are some silent, lonely actors on cosmic stage. But breaking news from the 247 meeting of American Astronomical Society in Phoenix has just changed everything. New research suggests that dark matter and the neutrinos aren't just passing each other in the night, they might be talking to each other. If this is a secret conversation is real, it does not just add up a new line to our physics books, it sets the entire standard model on the fire. So today we are dividing and diving into this breakthrough that could finally unmask the dark side of cosmos. So before we get into this breakthrough, we must understand who are the players, and first let's find out about neutrinos. The physicists call them ghost particles for a reason. They have almost no mass, no electric charge, and they travel at nearly the speed of light. So right now, as you watch this, about 100 trillion neutrinos are passing through your fingernail. And they are passing through the earth, through the lead walls, and through the entire stars as if they weren't even there. No, so this is something which is very interesting. And for a long time, we thought that neutrinos are massless. And we now know that they have tiny particles, they are tiny bit of weight, but they are so elusive that detecting them requires a massive vat of liquid xenon buried miles underground as a giant cube of ice at the solar South Pole. And they are the ultimate introverts of particle world, and they simply do not like to interact with anything. So that's interesting, so some particle which are not interacting with anything at all. So then there is a dark matter. If neutrinos are ghost, dark matter is graveyard itself. It makes up about 85% of all the matter in the universe. We can't see it, we can't touch it, we doesn't reflect the light. So that is something which is very mysterious and definitely very interesting. So the only reason we know it exists is because of the gravity. Without extra pull of dark matter, the galaxy would fly apart like a spinning wet umbrellas. So for the last 50 years, the standard model of cosmology model has operated on a very specific assumption. The dark matter is cold and collisionless. So that is something which is now actually we are reflecting, we are discussing, and we are finding out more clues on that. So that it means that it is heavy, slow moving, and most importantly, it does not interact with anything except gravity. So it does not even talk to itself, and let alone other particles, which is again not interacting. Now, but that assumption has actually run into a massive problem. So this brings us to 2026 AAS meeting. A team of research, including the scientists from the University of Stafford and the University of Hawaii, presented data that might have just solved one of the biggest headache of the astronomy. And here is the issue. So when we look into the early universe using the cosmic microwave background, our model actually tells us exactly how clumpy the universe should be today. The gravity should have pulled the matter together into a dense cluster. But when we look at the modern universe using the dark energy camera and gravitational lensing, we see something strange. The universe is actually less clumpy than it's supposed to be. It is too smooth. It is like baking a cake and finding it half the weight you expected. Though half the height actually you have expected. So as AAS research suggests, the reason for this smoothness, it is momentum exchange between dark matter and the neutrinos. So imagine dark matter as a heavy cloud of people trying to huddle together. Now imagine neutrinos as a swarm of high-speed ghosts flying through them. And if there is even a tiny microscopic interaction, a secret conversation, the neutrinos would essentially bump into the dark matter. So this tiny pressure from the neutrinos would push the dark matter apart, preventing it from clumping as tightly as gravity wants it to. So this is the direct interaction that physicists have been hunting for decades. So why this whole scenario, this whole concept is such a big deal? Because according to the standard model of particle physics, this shouldn't happen. The standard model is most successful theory in history, and it explains everything from from why the sun shines to how our smartphone works. So, but if it has a glaring hole and it has no explanation for the dark matter, so if the dark matter interacts directly with the neutrinos, it means there is a new force or a new particle mediating that conversation, and it would mean that the neutrinos, the light weight of the universe, are actually the bridge between the world we can see and the dark matter world we can't. So that's very interesting and definitely challenging concept. So if confirmed, and it gives a particle physicist a smoking gun. Instead of looking for dark matter in the dark, they can look at how neutrinos behave and work in the backyard. And if it's like finding a footprint in the wood, even if you can't see the animal, you now know exactly what you are tracking. So now from here, what next? How do we prove the ghosts are actually talking? So researchers at AAS pointed to two key tools. Firstly, gravitational lensing. So by watching how this dark matter bends the light from the distant galaxy, we can map its distribution with extreme precision. If the map continues to show a smoother universe, the case of neutrinos interaction actually grows. So, and the second point is that we have the next generation of telescope, like the Nancy Grace Roman Space Telescope, and it will actually look further back in times and than ever before, and allowing us to watch this conversation happening in a real time across the cosmic history. So we are standing at the edge of new era. For centuries, we are actually looked at the dark universe as a mystery, or we might never solve, because it has been difficult to really finding out these aspects in cosmology. But if the ghost and the shadow are talking, we might finally be close to the understanding of language of cosmos. The universe is lot noisier than we thought, and we just had to learn how to listen the ghost. And if you want to keep up with these kind of latest finding from the AAS meeting and more breakthroughs in the new physics makes actually sure to hit the subscribe button, and turn on the notification. This new findings and the next few years we are going to be a wild rider for science. So what do you think about this? Isn't it interesting to really find out and dive deep into this topic? Is the dark matter finally revealing itself, or is there another hidden mystery in the data? So let's talk about this and more in the comments below. And thanks for watching. Stay curious and see you again in the next one.